तो आज के सेशन में we'll discuss this logistic regression, and with logistic regression हम we'll start with classification. हमने regression देखा for supervised learning, ठीक है. we'll उसका एक और component जो था that is your classification algorithm. So we'll start with logistic regression आज. In this आज हम discuss करेंगे होता क्या है, what is it. We'll build some mathematics, some algorithms, and then we'll formally implement it. So let me head back to my OneNote. Just tell me if it is visible or not. Just tell me if it is visible or not. Visible है? Perfect. 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 देखो अभी तक हमने जितना कुछ देखा, it was something like कि given this x values, ठीक है, given this x values हमको इस लाइन के थ्रू कुछ प्रेडिक्ट करना था, राइट. कोई पॉइंट हमको दिया रहा है, लेट्स से x डैश, तो वी हैव टू फाइंड सम न्यूमेरिकल वैल्यूज, राइट. कुछ यहाँ पे हो जाता, लेट्स से दिस इज y, तो दिस इज y डैश. हमको ये प्रेडिक्ट करना था यूजिंग दिस बेस्ट फिट लाइन. अभी तक हमने यही किया, वंशिका, शशांक. So regression was like somewhere down the line we have to predict this point जो इस लाइन के आसपास आ रहा हो. Now we'll head back to see what a classification problem is. अब classification is somewhere like, जैसे for example मैं एक example दूंगा. Let us say you have a student age, ठीक है. You have these students CGPA, ठीक है. These are your x values. These are your x. Based on these two things, you have to predict कि इसका प्लेसमेंट लगेगा या नहीं. So it can be either a yes or a no, right? या तो प्लेसमेंट होगा या प्लेसमेंट नहीं होगा. So you have some, let's say 18, 20, 25, and CGPA let's say 7.7, 6.3, 9.2, something like this. So you can say इसका प्लेसमेंट लगा, इसका प्लेसमेंट नहीं लगा, इसका प्लेसमेंट लगा. Kind of this. एक ये तरीका हो सकता है, या एक ऐसा भी हो सकता है. See, if I talk about this specific one, what are the two different outputs जो यहाँ possible है इस problem के लिए? What are the two different outputs?
Yes or no?
Output can be either a yes, right, या no
or no.
So if I talk about mathematically, can I say that this is either 1 or 0? 1 if it is true, 0 if it is false. So this kind of problem in which you have only two output set, these are known as binary classification. ठीक है, binary classification. ऐसा भी हो सकता है, you can have something like this कि you have some pictures, like P1 is your picture, P2 is your picture, P3 is your picture, and something like that. And you have this prediction if it is a cat, if it is a dog, if it is a human, something like that. ऐसा भी हम classify कर सकते हैं, right? Right? Either that picture could be a cat, dog, human, or whatever else, जो भी तुम्हारा मन है. So these kind of problem in which you have different classes, more than two, multi-class, these are known as multi-class classification. So let me tell you, जो हम आज देखने जा रहे हैं हम, this logistic regression, it works very nicely with this kind of problem. It works very nicely with this kind of binary classification. Let me show what it is. हाँ वंशिका.
भैया एक बार मल्टीपल क्लासिफिकेशन फिर से रिपीट कर दीजिए.
अरे फॉर एग्जाम्पल जैसे हम लोग देखते हैं ना कि कुछ कुछ पिक्चर्स रहता है, हमको बताना होता है कि ये डॉग का है, ये कैट का है और समथिंग लाइक दिस. अगर सिर्फ कैट और डॉग का बात करूं मैं यहाँ पे, सिर्फ कैट और डॉग का, सिर्फ अगर इतना मेरे यही दो मेरे को प्रिडिक्ट करना है, तो दिस इज अ बाइनरी क्लासिफिकेशन. दिस इज अ बाइनरी क्लासिफिकेशन. बट अगर दो से ज्यादा कर दिया मैं, तो दिस इज अ मल्टी क्लास. ठीक है, परफेक्ट. So let's see what it is. Let us have something like this. Your data set has something like this. This is your y, this is your x. So I'm assuming you have your data something like this. Let me put it in points. These are your one class. These are your other class. Okay. So for the sake of, for let's say, this is, let me say this is your CGPA and this is your placement, right? So I अच्छा रुको, अभी इसको अभी नहीं रहने दो, अभी let me not, उस पे भी आएंगे पहले. So I am assuming that this entire bunch is one class of problem, and what I'm saying, this is your one class. This is, let's say, your class 1, and this is, let's say, your class 2. Now class 1, class 2 could be anything. You can say as placement हुआ, placement नहीं हुआ. This can be the set of people जिसका placement हुआ है, जिसका placement नहीं हुआ है. Something like that. It could be anything. So जैसे हमने regression में देखा, if I have to make some kind of line, obviously हम एक line के साथ शुरू करेंगे. If I have to make some kind of line, there has to be a line जो इन दोनों part को separate कर पाए. What I mean by this, there has to be a line something like this जो ये इस क्लास को मतलब सेपरेट कर पाए. What do I mean by this? That let's say this is your line ax plus by plus c is equal to 0. This is your line. So whatever point it is, if it is in the right direction of this line, it belongs to class 1. कह सकते हैं. And whatever points are there which are on the left hand side of this line, it belongs to class 2. कह सकते हैं? Just tell me. Can I say like this? But तुमने देखा होगा whenever we were dealing with linear regression, like हम जब linear line के साथ हम जब work कर रहे थे, तो our values, जो हमारा values जो भी हमारा आएगा, this should not be belonging to this range. इससे ऊपर भी हो सकता है, इससे नीचे भी हो सकता है, right? Kind of. Can I say? Obviously 1 के ऊपर भी जा रहा था value, right? 1 से 0 से नीचे भी था, negative में भी था, something like that. Or let me say, let us say this belongs to 1 and this belongs to 0. So what I say, if let's say this is your hypothesis function, अगर इसका value 0 आया, so I can say कि it belongs to class 2. अगर इसका value 1 आया, तो it belongs to class 1, kind of. क्लास 1 अगर तुम इस प्लेसमेंट वाले के साथ बात कर रहे हो तो 1 कैन बी फॉर लेट्स से प्लेसमेंट हुआ yes and this could be for no और vice versa तुम्हारे ऊपर है जिसको तुम जो नोटिफाई करो that is something purely तुम्हारे ऊपर कोई इसमें restriction नहीं है so you see जब हम ऐसा ऐसे डील करेंगे इसको when we are dealing with linear regression your hypothesis function would never be in this range what I say that this will not hold true for all values of xi comma yi what I say that whatever value you may take for xi and yi your linear regression problem your linear line would never be able to map this in this codomain कुछ वैल्यूज के लिए हो सकता है कुछ वैल्यूज के लिए नहीं हो सकता है फॉर सम वैल्यू इट मे होल्ड ट्रू फॉर सम वैल्यू इट मे नॉट दैट इज समथिंग वी डोंट वांट वी ओनली वांट either go for 0 or go for 1 give me 0 or give me 1 nothing else understood Vanshika Shashank okay so if I show you if acha so you see if our hypothesis if your hypothesis function was something of the order theta naught plus theta 1x what we see your hypothesis function will not belong to this value for all xi and yi so whenever we have this so the issue arises with this function ये function के कारण हमारा ये value नहीं आ पा रहा so what would happen let us say what if we use some other function एक और चीज देखते हैं एक और चीज देखते हैं let us have our data set something like this if this is your 1 and if this is your 0 and if I have to make some kind of a regression line that may follow it can I make it something like this right I can make my hypothesis line something like this that whatever value you may take if it lies right to this that value is that value belongs to this prediction 1 and whatever value lies on the right left hand side it belongs to your prediction 0 right this is your x this is your y what would happen if I take some extreme value something like this कितना आगे है कोई value x के range में कुछ बहुत आगे है value so you may observe that your regression line changes something like this obviously regression line will change okay your regression line will change because your input x is changing so corresponding your slope will change correspondingly your intercept will change and you will have a regression line something like this h prime x if you just take it for this example पहले वाले लाइन के हिसाब से if you take for this line it belongs to the prediction 0 पहले वाले लाइन के हिसाब से it is on the right left hand side so this point would belong to prediction 0 or your class 0 but because of some outliers because of some extreme values the regression line has changed and now this value lies to this one because it is lying on the left hand side can I say something like this अब हुआ ये कि एक सिर्फ एक एक्सट्रीम वैल्यू आ गया जिसके कारण मेरा पूरा जो मेरा हाइपोथेसिस फंक्शन था वो चेंज हो गया और उसके कारण आई एम गेटिंग सम इनकरेक्ट प्रेडिक्शंस समथिंग लाइक दिस So you see, this is another demerit of this regression line. कि if we put some extreme values, हमारा regression line change हो जाएगा, और whenever your regression line changes, chances are you'll start predicting some wrong outputs. So mathematically there is a function take it to 1, this is 0. So there is this very beautiful function which is known as sigmoid function, which happens to be something like this. Oh, just a second. It is a very beautiful function, and this midpoint is 0.5. This is known as sigmoid function. This is a graph of sigmoid function. So see what is happening. Whatever value do you take for x which is greater than 0, it will map it to 1. जो भी value 0 से ज़्यादा है, you will have the output as 1. And whatever values which is less than 0, it will map it to 0. What I mean, that this function, let us say your sigmoid function as something like x. Let us denote it with this. So this function, what will do, it will give you 1 if your x is greater than 0. It will give you 0.5 if your x is 0.5. Oh, my mistake. And it will give you 0 if your x is less than 0. यही हो रहा है. If you see this graph, ये सारे values के लिए your value is 1. ठीक, अगर हम यहाँ पे आएंगे तो the value is 0.5. And if you see here carefully, whatever negative values you may take, okay. So if I have to mathematically tell you about this, or you may do one thing, just a second, let me show it to you. I want you all to open this site which is known as Desmos. Okay, let me show it to you. Present this Desmos. You may use this site. Let me tell you how to plot it. Let me use it. See. So अभी तक मैं जो बता रहा था, it was something like, let us have a regression line, something as, let's say 3x plus 2y plus 2. For example, this is your regression line, is equals to 0. Okay, this is your regression line. Okay, let me have this is your regression line, for example. So what I said, key, for example, if your point is towards the right of it, what I mean by right of it, whatever point is there, if it is lying in this, that is in this shaded region, let us take it for class 1.
You are not.
Am I visible? Okay, perfect. So whatever value you are having for this shaded region, it should be equal to 1, and whatever value you had it in this region, it should be for 0. So you have a very interesting function. Let me open it, which is known as your sigmoid function, which is actually useful here to get your values. If I'm talking about mathematically your sigmoid function would be something as of, let's say, your hypothesis. So this is equals to 1 over, okay, let me take it for simple. Let me make it simple. Thoda sa. Let me take it for z. 1 over 1 plus e raised to the power minus x. This is your sigmoid function. This is your sigmoid function. If I go back to Desmos, yes, if you go back here and see, if you try to plot its graph, let us say my y is equals to 1 plus 1 over 1 divided by 1 plus e raised to the power minus x. Let me zoom it out a bit. Let me have a line. Y is equals to 1, y is equals to 0. We have this. So if I plot it here, you can see there is this very interesting curve, which as your x reaches infinity, it is reaching to value 1, and as it reaches minus infinity, you may see here, as it reaches minus infinity, the x as it reaches minus infinity, it is going to that value 0. So we'll use this function specifically because see क्या हो रहा है कि whatever value you're having, as जैसे हमने वहां देखा था, जैसे जैसे एक्सट्रीम वैल्यू हो रहा था हमारा रिग्रेशन लाइन चेंज हो गया, और रिग्रेशन लाइन चेंज हो गया तो हमारा आउटपुट चेंज हो रहा था. बट यू मे सी whatever however large your value x is, the function is mapping only to 1 ही तक जाएगा for whatever large case of x you may take, and whatever, like in the opposite extreme negative if you take, it is only going to 0. So we can say this function is not varying as per the outlier we are giving it. Okay, so we'll use this very interesting function, but uh, see how we'll use it. Technically, this function is used on the hypothesis. This function is used in hypothesis. How I mean to say that, like, इससे पहले हमने देखा that our hypothesis function was something like beta naught plus beta 1x. This is for linear regression, right? This was for linear regression. Am I correct? So जो issue आ रहा था इसके कारण ही issue आ रहा था. Whatever issue we were having, we are having with this function. So what I say, okay, let us have our hypothesis function as 1 over 1 plus e raised to the power minus gx. This is for logistic regression. What is this function gx is, we'll leave. अब this gx is nothing but this thing. We are mapping that regression line as an input here. What do I mean? We have it beta naught plus beta 1x. So you may say, if you will use this and this, your hypothesis function reduces to this value. This is your hypothesis function. Very simple. कुछ नहीं है. This is the function we'll use to produce our output. ठीक है? This will be the. Let us talk about if this is the function, what would happen to our loss function? हमारा जो error function था उसको क्या होगा? ठीक है? हाँ वंशिका.
वही यहाँ पे e टू द पावर माइनस बी नॉट प्लस बी वन एक्स में वहाँ पे माइनस दोनों इसमें नहीं होगा. अच्छा ठीक.
Perfect. ठीक है? Perfect. See, so let us see what would happen to our error function. Let me recall it for you. Your loss function j, okay, your loss function j. What was your loss function? If I let us take it for some parameters, that was this I is equals to 1 till m, your yi minus y hat square, यही था if I take it for yi hat. This was your error function if I take it for yi and yi hat. So yi hat is what? Your hypothesis function, right? This was your hypothesis function, correct? Perfect. So this was for your linear value. But if I talk about what would be the loss function for your logistic regression. So loss, you may say error, you may say cost function, whatever you may say. Cost function for logistic regression. So it happens to be dependent on your y. Acha, what are the two different y's we are getting? We are either getting a 0 or we are getting a 1. यही तो हमको मिल रहा है as an our output, be it predicted or be it your actual values. It is either 0 or it is either 1. So we may say your loss function j would be like it is minus log of your y hat, or let me replace it with hypothesis function. X, if your y is 1 and it is minus log of 1 minus hx if y is 0. This is the loss function. मैं वो वाला मैथमेटिक्स स्किप कर रहा हूं जहां पे हम इसको डिराइव करेंगे because that is something I don't think it is necessary as of now, but this is the loss function. अगर if your y is 0, you'll have this minus log of 1 minus hx, and if your y is 1 you have this essentially. If I plot a graph, if I try to plot a graph, you may see this is your loss function, this is your hypothesis function, this is 1. So for the first case, you may see, your line would be something like this. And for the second type, when your y is 0, it would be something like this. H, X, J, this is 1. Line would be something like this. You may actually try to plot the graph, no issues, but you have that line. What it says, ki as your y goes, as your hypothesis function goes to 0, you will have a very high loss function. So the ideal case, it should go towards 1. In other case, as your hypothesis function goes to 1, the loss is very high. Okay. So using all these things, can I model it like this? That for your x and y, because ultimately we defined hypothesis on x and y. Sorry, your loss function on x and y. So your hypothesis function would be minus yi. अभी कैसे आया मैं बता रहा हूँ. See, if I'm taking For ith value, your loss function is this. अब ये आया कैसे? Try to put y is equals to 1. If you take y is equals to 1, this term would be 0. Right? अगर तुम y को 1 लोगे तो 1 minus 1, 0. So essentially this term is 0. And is so you have this function यहाँ पे. If you, y is 1, यहाँ पे 1 आ गया and you have this value. Try to put y is equals to 0 in this thing. अगर y 0 हो गया तो ये 0 हो गया, ये पूरा 0, बचा मेरे पास अब ये. So this is a single equation which summarizes जो हमने ऊपर पूरा लिखा. This function summarizes जो हमने ऊपर पूरा लिखा. If I am only taking for ith value, तुम पूरा क्लिक करोगे तो भी you will have only this value, because if you want to take it for the entire set, you may have, let us say for ith value, you may have something like j x comma y. It would be a summation I is equals to 1 till m value. Let us say if you have m data set, you will have minus yi log of hx minus 1 minus yi log of 1 minus hx, and for ith loss function, hypothesis function. So this is your loss function. ठीक है? This is a loss function. Now let us see how do you get the best values. How do you get the best values? What do I mean to say? Again, you may see your hx was what? 1 over 1 plus e minus beta naught plus beta 1x. यही था. This was only for two features. If you want to take n features, it would be something like h of x would be something like 1 over 1 plus e raised to the power minus beta naught plus beta 1 x1 plus beta 2 x2 till beta n xn. So हमने देखा था, if you would remember from multivariable linear regression, I can actually write it like something like this. If you could recall, I can write it like this. Perfect. Ab, you may say, if I have to get the best value of hx, I would be able to get the best value of beta. Am I correct? अगर मेरे को prediction अच्छा करना होगा, हमको hx सही चाहिए, because अगर हमारा hx सही होगा, because see, यहाँ पे क्या हो रहा है? Y is either 0 or 1. Correct? The only thing which is varying here is your hx. hx is something which we have a control of. हमारे पास इसका control है. So your hx is something we have to take care of, and this hx is depending upon this beta. Right? It is depending upon our beta. So if you have to get a very nice and a very accurate value of hx, you have to get a very appropriate value of beta. Correct? What I say, to minimize your j, what you have to use, you have to get good h of x. And how do you get good hx? Get good beta. And how do you get good beta? हमने देखा था, we'll use gradient descent. हमने देखा था, one way is you can do it mathematically, no issues. वो जो equation था xt minus x करके एक equation था normal form, you may use that and you'll get the best value. But inverse operation हम क्यों करेंगे? Let us do it with gradient descent. So see, if I have to get a good beta, can I say by gradient descent, by gradient descent, your beta j should be equal to beta j minus your learning rate times del of your cost function. Can I say this using gradient descent? Sashank? Perfect. I can say this, yeah. Obviously, I can say this. I can say this. Perfect.
थोड़ा ऊपर दिखा दो एक बार.
To get your minimum cost function, you need a good value of hx. And how do you get a good value of hx? You need a good value of beta. Because see, hx में you have this expo e, which is constant. This is constant. इस पे तुम कुछ नहीं कर सकते. X is something which is constant, जो तुमको data set में दिया रहेगा. So you cannot do with it. You can only work with this beta. और transpose is just an operation. Beta सही होगा तो उसका transpose भी सही हो जाएगा. So can I write something like this? Can I write something like this कि तुम्हारा जो j of beta, that is a loss function, it is something like 1 over m, 1 is equals to 1 till m, something like minus yi, okay, yi log of hx minus 1 minus yi log of 1 minus hx. ये पूरा एक टर्म है, ये पूरा एक टर्म है. This is for ith value, this is for ith value. Yeah, this is your loss function essentially. So अब यहाँ पे you see you have this log of hx, right? You have this log of hx. Should we calculate? दिखता है log of hx क्या होता है? Log of hx it is what? Log of 1 over 1 plus e raised to the power minus beta transpose x. This is what it is. If you would remember logarithm, log of a by b is what? Log of a minus log of b. यही होता है. Let us implement it here. You will have log of 1 minus log of 1 plus e raised to the power minus beta transpose x. And log of 1 is 0. So it is minus log of 1 plus e raised to the power minus beta transpose x. आया आया सबका? वंशिका, तुम लोग नोट कर रहे हो ना? ऐसा नहीं हो कि भाई इधर सिर्फ लिख रहा हूँ. चल अब हाँ, अब now let's see कि what this log of 1 minus hx is. Let's see this. Log of 1 minus hx. This is what we want to calculate it here. Okay. Pretty easy. Log 1 minus 1 over 1 plus e raised to the power minus beta transpose x. Take the LCM, you will have log 1 plus minus 1, 1 plus 1 and 1 is cancelled. You have something like log minus beta transpose x over 1 plus e raised to the power minus beta transpose x. आया सबका इतना? If you would use that property again, you will have something like.
भैया एक मिनट स्क्रॉल कर दीजिए.
अरे हमने बस यहाँ LCM लिया, 1 and 1 we have cancelled it out. We have only this term in the numerator and this term in the denominator. बढ़े आगे. Now let us reduce this term. This is log of e raised to the power minus beta transpose x minus log of 1 plus e raised to the power minus beta transpose x. अब तुम इसको ऐसे भी सिंप्लीफाई कर सकते हो. दिस इज माइनस बीटा ट्रांसपोज x log of e minus log of 1 plus e raised to the power minus beta transpose x. ये प्रॉपर्टी आते ही होगा. दिस इज दिस प्रॉपर्टी log of e raised to the power m is m log a and log e is 1. Log e is 1. ठीक है, log e is 1. So let me write it again. This essentially reduces to minus beta transpose x minus log of 1 plus this. So this is your log of 1 minus hx. बहुत इजी है ये भी, कुछ ज्यादा इसमें रॉकेट साइंस नहीं है. इट इज जस्ट कि थोड़ा सा मैथमेटिक्स है, ये मैं डील करना चाहता हूँ. बिकॉज तुम कोई भी अगर यूट्यूब चैनल पे जाकर देखोगे, दे हैव ओनली कवर्ड दिस पार्ट. लॉजिस्टिक रिग्रेशन में वो सिग्मॉइड फंक्शन होता है, दैट्स इट, खत्म. एंड देन इम्प्लीमेंटेशन एसके लर्न्स है. सो दिस वाज योर लॉजिस्टिक, दिस वाज योर लॉस फंक्शन. अब रुको, दिस वाज नॉट योर लॉस फंक्शन. हमने 1 माइनस एच एक्स कैलकुलेट किया, हमने लॉग एच एक्स कैलकुलेट किया. ठीक है, नाउ लेट अस पुट दिस थिंग हियर.
जरा ऊपर स्क्रॉल कर दो.
कौन सा?
बस यही होंगे.
बड़े आ गए शशांक? So let us do what? Let us put the values here. इस इक्वेशन में अब हम पुट करते हैं. Whatever values we have got, let us put it here. Let us put it there. So I'm only doing it for one value, then we'll use this summation. So if you want to calculate it for ith value, this beta, this will essentially reduce to minus yi of minus log 1 plus e raised to the power minus beta transpose x, right? Because हमने देखा, this is what we have. ठीक है, let us do it for another value.
ये क्या किया संजय लास्ट स्टेप?
देखो, रुको रुको रुको, मैं बता रहा हूँ. What was our loss function? Our loss function was this thing. This was our loss function. ठीक है, ये था हमारा पूरा. तो ये तो पूरे m वैल्यूज के लिए है. आई एम ओनली डूइंग इट फॉर वन वैल्यू. पहले एक वैल्यू के लिए देखते हैं. So what I'm saying is let us take it for ith value. So if I'm taking it for ith value, ये क्या हो जाएगा? Minus yi log hx corresponding to that value. ठीक है, minus 1 minus yi and this whole term. ये हो जाएगा एक वैल्यू कोई भी ith वैल्यू के लिए। सो अब ये जो मैंने यहाँ पे log hx है, log 1 माइनस एच एक्स है, ये हमने अभी अभी डिराइव किया है यहाँ पे, अभी देखा हमने। आई एम ओनली पुटिंग दिस वैल्यू हेयर, लेट अस पुट दिस वैल्यू, let us put let us put those values for some ith value. What it would be, minus yi, and log this is what, your minus 1 minus, ठीक है, this is your 1 minus log 1 plus e raised to the power minus beta transpose x। आया शशांक इतना पार्ट कहां से आया है? ये वैल्यू हमने ऊपर डिराइव किया था, यस, ये वैल्यू अभी हमने डिराइव किया है, इफ यू वुड रिमेंबर। So let me write it नीचे, कितना पे हो जाएगा, लेट्स सी। But this was your 1 minus hx. Now let's do what? Let us multiply this thing. Let us multiply this thing. So minus and minus would become positive. This would be yi log 1 plus e raised to the power minus beta transpose x. कनिष्का तुम तो थोड़ा लेट आई हो, तो हो सकता है तुमको मैथमेटिक्स मतलब थोड़ा स्किप करें, बट मेक श्योर यू जस्ट वंस आई अपलोड इट ऑन यूट्यूब यू जस्ट रिवाइज इट, कुछ ज़्यादा रॉकेट साइंस नहीं। लेट अस ओपन दिस थिंग। So if you open it, minus, okay, so you'll have something as minus 1 से इधर गया, तो this is log e raised to the power minus beta transpose x, this minus and minus plus log 1 plus e raised to the power minus beta transpose x, and then minus minus positive, and this is positive, plus yi log e raised to the power minus beta transpose x, and then minus minus positive, and then minus, and then you have this last में minus yi log 1 plus e raised to the power minus beta transpose x। this is, अब हमने ब्रैकेट ओपन कर लिया, ये टर्म पूरा यहां हो गया, ये पूरा जो मल्टीप्लाई में है वो ये 1 2 3 4, ये 4 टर्म्स हो गए, ठीक है। पहले के साथ ये रहा, दूसरे के साथ ये रहा। Now let us, if you would take it very, if you observe something, this term and this term are equal। देखो ध्यान से, दोनों सेम चीज लिखा हुआ है, और माइनस साइन के साथ है तो आई कैन कैंसिल इट आउट, आई कैन कैंसिल इट आउट। देखो ध्यान से, दोनों सेम चीज लिखा हुआ है। So can I write it something like it? What you are left with? What you are left with? Let's see. Can I write this thing as minus of minus beta transpose x, log हमने देखा था minus beta transpose होगा log of e raised to the power minus beta transpose x, it is beta transpose x minus के साथ, and this minus minus is plus, so I'm simply writing beta transpose x for this term, ठीक है। Now let's see for another, what next term we have. We have this as next term, plus yi log e raised to the power minus beta transpose x. ठीक, you have this term, nice, and we have next this thing. मैं क्यों किया मैं बता रहा हूँ, beta transpose x. तो हमने रीअरेंज किया बस, और कुछ नहीं किया. ठीक है, हमने बस थोड़ा सा इधर उधर किया एंड दैट्स इट, नथिंग एल्स. अब ऐसा करते हैं 1 मिनट के लिए. लेट अस टेक इट लाइक दिस. लेट अस ओपन दिस ब्रैकेट. So we have beta transpose x plus yi into minus beta transpose x. ठीक है? Can I write it like this? Yes, I can write it. Yes, I can write it like this. Okay. हाँ. Just a second, just a second. कुछ गलती नहीं किया ना मैं? And this is as usual log of 1 plus e raised to the power minus beta transpose x. As now let's see, can we even simplify it? हम इसको और simplify कर सकते हैं. Can we see something कुछ हमको मिल जाए? So you see you have a log function here and you have a plus here. So can we make this into some log? No, we cannot make it in some log. But हाँ, ये I can make it in a log function जो हमने पहले देखा था. बिकॉज हम लॉग का प्रॉपर्टी यूज करना चाह रहे हैं इस पूरे फंक्शन, इस पूरे आंसर जो भी हमको एक्सप्रेशन मिला इसको सिंप्लीफाई करने के लिए. सो इफ आई जस्ट रीशफल इट, यू हैव समथिंग एज log e minus beta transpose x plus log 1 plus शायद log a plus log b कोई प्रॉपर्टी होता है ना. फॉर एग्जाम्पल there is this property log mn is equals to log m plus log n. ये प्रॉपर्टी होता है. So we'll use it. So can we club it together? Yes, we can club it together. This would go as 2 minus yi beta transpose x. So if you would simplify this expression, you will get something as log 1. If you will simplify it, just a second. Oh, my mistake. My mistake. यहाँ पे ये minus नहीं होगा because it is only beta transpose x. It is only beta transpose x. So ये minus यहाँ नहीं होगा. Just a second. So if you will multiply, you will see कि this thing and this thing are reciprocal. तो ये दोनों कट के 1 हो जाएगा. So you will have e raised to the power beta transpose x plus 1 minus yi beta transpose x. Let me rearrange it थोड़ा सा. Log 1 plus e raised to the power beta transpose x minus yi beta transpose x. So this is what your ji is, जो हमने देखा. Now let us use gradient descent and differentiate it. Let us use gradient descent and differentiate this thing. सिर्फ इसको differentiate करते हैं. हाँ वंशिका.
भैया एक मिनट स्क्रॉल कर दीजिए जरा.
और
नहीं बस.
देखो हमने ये ब्रैकेट में लिया. If you will multiply it by 1, you'll have this. If you will multiply it by minus, same. देखो पावर में ना तो ये रेसिप्रोकल हो गया पहले टर्म का. तो रेसिप्रोकल मल्टीप्लिकेशन में जब करोगे तो ऊपर नीचे कट के 1 आएगा. तो you have this 1 and your last term is as usual. अच्छा, since we are talking about x, we are talking about ith term, let us take it for xi, ith value. ठीक है, ये मैं ऊपर तुम इसको चेंज कर लेना. This is for ith value of x, and ऊपर तुम लोग अपने उस हिसाब से कर लेना. चलो, should we differentiate it now? Because ये हमने जो देखा ऊपर अगर gradient descent हो, so we have to differentiate j with respect to beta. ठीक है, we have to differentiate j with respect to beta. तो ठीक है, let us differentiate it. How can we actually differentiate it? If you see here, उसके पहले let me show you something. ये बीटा और x है होगा कैसे? If you would see something like हमारा जो if I'm talking about your function, वो कुछ इस तरह से होगा. It would be something like this: beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. कुछ इस तरह से होगा. Something like this, right? शशांक, कनिष्का. अच्छा, let us take it in a table form. Let us say this is your x1, this is your x2, this is your x3, this is your x4, something like this, and you have some y. So this would be what? x1 corresponding to your first row, x2 corresponding to your first row, x3 corresponding to your first row, x4 corresponding to your first row. This would be x1 corresponding to second row, x2 corresponding to second row, and so on. Right? Correct? Okay. So if I'm talking about x1, so this x1 would be what? This would be this vector, x11, x12, x13. This would be this vector, right? अब आते हैं यहाँ पे. अब आते हैं एक्चुअल डिफरेंशिएशन. मैं क्यों मैं बता रहा हूं अभी. लेट अस डिफरेंशिएट सी. हम डिफरेंशिएट कुछ बीटा जे, बिकॉज हो सकता है if I'm talking about beta 1, beta 2, beta 3, something like that. These are your j's. So if I'm talking about beta, let's say 2, if I'm only talking about this term, rest all the terms would be what? Constant. With because हम देखो partial differentiation कर रहे तो उसके respect में तो सब constant है. Correct. शशांक, कनिष्का. अब partial derivative है. If I'm only talking about with beta 2 तो बाकी सब तो constant है. अब ये x2 में x2 would be what? x2 would be what? x21, x22 and so on, right? ये second row पूरा. Correct? Perfect. हमको बस यही बताना था. Because जब हम differentiate करेंगे तो वो चीज आएगी यहाँ पे. Okay, let us differentiate our expression जो हम यहाँ मिला है. Let us differentiate this thing. तो log का differentiation क्या होता है? 1 over this.
संजय तुम ये x2 वाला क्या बताया था अभी?
अरे what I said, देखो इधर. अरे यार, मैंने ये बोला, जैसे यहाँ ध्यान दो कि if this is your regression equation, if let's say we are differentiating it with respect to beta 2, बिकॉज दे बीटा जे है तो कुछ जे वैल्यू होगा 1 2 3 4 समथिंग. So if you are differentiating it with respect to beta 2, उसके साथ कुछ x2 assigned है वेक्टर, फीचर वेक्टर. अभी x2 क्या है? ये पूरा रो, सर ये पूरा कॉलम, ये पूरा कॉलम है. अब ये पूरा कॉलम क्या है? x12 x22 x2 ऐसा, राइट? यही है ना, ये मैंने बताया. तो जब हम डिफरेंशिएट करेंगे तो वो चीज आएगा. अच्छा, थोड़ा सा इजी हो जाए तुम लोग को डिफरेंशिएट करने के लिए, मैं यहाँ सामने लिख देता हूँ. So Ji is, let me write your Ji is with respect to beta. This was what? Log 1 plus e raised to the power beta transpose xi minus yi beta transpose xi. ये है हमारा फंक्शन, लॉस फंक्शन, राइट? और लेट्स डिफरेंशिएट इट. If you differentiate this thing, you will have something as 1 over 1 beta transpose x. And now let us differentiate this thing. अगर तुम इसको e का differentiation क्या होता है? d of e d होता है, correct? So it would be this only. ये जो expression है यहाँ पे, यही expression रह जाएगा, into e raised to the power beta transpose xi. So your first term is differentiated. Let us differentiate this thing. Correct? Differentiate. If you would differentiate this thing with respect to some beta j, if you would differentiate it with respect to some beta j, अगर हम यहाँ बीटा 2 के रिस्पेक्ट में डिफरेंशिएट कर रहे हैं तो ये बाकी टर्म तो कांस्टेंट है, तो ये तो 0 हो जाएगा. करेक्ट? करेक्ट? बिकॉज सी, ये बीटा ट्रांसपोज क्या है? बीटा ट्रांसपोज इज व्हाट? Your beta transpose is what? This is a row vector of beta naught, beta 1 and so on. So we will be only having, अगर तुम इसको differentiate करोगे तो we would be only having beta j, जिसको हम differentiate, बाकी टर्म तो 0 हो गया. अब बीटा j को बीटा j से differentiate करेंगे, it would be 1. शशांक समझे? अब yi की कांस्टेंट है तो this would be something like this. So beta j differentiated with beta j, this gives 1. Now xi is what? Xi is the entire set of feature, right? Entire set of feature. Xi is what? This thing, entire set of feature. But if you would differentiate, let's say beta 2, you have only x2 as your coefficient, and x2 is what? This thing. ठीक है? So let me erase this one. One का तो काम है नहीं. It is understood. So it would be something like ith value corresponding to jth column. ठीक है? ith value corresponding to jth column, जैसे यहाँ पे था. कोई एक वैल्यू के लिए अभी हम सिर्फ कर रहे हैं, अब पूरे के लिए करेंगे तो समेशन ले लेंगे इसका अलग अलग वैल्यूज के साथ. सो दिस इज, लेट मी सिंप्लीफाई इट फॉर यू. थोड़ा सा सिंप्लीफाई कर दें. इफ आई वुड सिंप्लीफाई इट एंड, अच्छा एक मिनट. सो यू हैव ऑल्सो दिस बीटा एंड एक्स एक साथ, हम डिफ्रेंशिएट कर रहे हैं बीटा के साथ, तो दिस टर्म वुड ऑल्सो बी देयर एक्स आई. ठीक है? अरे ई का पावर ax को अगर डिफरेंशिएट करोगे डेल एक्स के साथ तो यू विल बी हैविंग ex इनटू दिस x. तो वही किया मैंने. अब इफ यू वुड टेक इट, अब यहां पे भी ये j होगा बिकॉज वी आर ओनली टेकिंग इट फॉर ओनली वन वैल्यू. सो उस वैल्यू के करस्पॉन्डिंग जितना रो होगा हम उसी के लिए बस करेंगे. ठीक है? अब if you would take it थोड़ा ध्यान से, this xi and this xij is common, तो एक साइड क्लब कर देते हैं. Let us club it together. What do I mean to say? Let us take this as common. So you would be left with just a second. Do we have something? कुछ कट सकता है यहाँ पे? कुछ नहीं कटेगा आज. Just have it. What I'm left with? E raised to the power beta transpose xi over 1. आएगा? आया सबका ये? आया? थोड़ा सा इसको और shuffle up कर देते हैं. If you will shuffle it up थोड़ा सा, you would be having this value.
ये थोड़ा सा ऊपर कर दो.
ठीक है? Now let us do one thing. इसको और सिंप्लीफाई कर देते हैं. ऐसा करते हैं, ऊपर नीचे इससे डिवाइड, न्यूमरेटर से डिवाइड कर देते हैं. मैं क्यों कर रहा हूं? बिकॉज सी, हमारा एम है ये फंक्शन लाना. हमने ऊपर नीचे इसे डिवाइड कर दिया. तो इफ यू डिवाइड बाय दिस वुड बी 1, this would be 1, and this value would be this thing, 1 over e raised to the power beta transpose x is what? E ka power minus beta transpose x, right? Let me make it थोड़ा सा अच्छे से इसको लिख देना. हमने क्या किया, मैं बोलता हूं यहीं पे अभी इसको डिवाइड कर देते हैं. अगर तुम डिवाइड करोगे तो यू विल हैव समथिंग एज दिस थिंग. हमने क्या किया? we have said we are dividing your numerator and denominator with e raised to the power beta transpose x. So you'll get this thing. अब let us shuffle it थोड़ा सा. You have a minus sign, minus आगे ले आए. So this function is what? If you could remember it, this is your hypothesis function. Let me scroll a bit for you. This was your hypothesis function. है? Is it? So can I write it like this? This was what? Your hypothesis function. So this was the differentiation of your J. तुमको अगर ये सीधे क्या बोलते हैं, if you want to calculate your entire logistic regression, you can have some nice value of J to calculate some beta. So this was your slope. ये रहा तुम्हारा slope. You can actually put learning rate here. You multiply. You'll have some values. You can see कौन से value के लिए क्या सही है. Mostly for 0.01 and 100 epoch, you will get the correct answer. But you may test it for yourself. That is I'm giving you as a homework. So this was all about the mathematics. Let us start with implementation. इतना क्लियर हुआ सबको जो आज मैंने कराया मैथमेटिकल पार्ट में? हाँ, थोड़ा सा ज्यादा रिगरस हो गया, बट अगर तुम एक बार खुद से करोगे, इट इज वेरी इजी. क्यों मैं कराया? बिकॉज सी हम अधिकतर क्या करते हैं, हम लाइब्रेरीज का यूज करके सीधे लॉजिस्टिक रिग्रेशन लिखे और हमको आंसर मिल गया. यू कैन यूज इट, बट मैं आज तो मैं लॉजिस्टिक रिग्रेशन क्या बोलते हो किस पे कराऊं? शुड आई डू इट विथ sklearn or should I do it with simple implementation? ठीक, विल डू इट विथ sklearn. और मैं वो वाला भी नोटबुक मैं तुम लोगों को सेंड कर दूंगा जिसमें मैंने लाइक sklearn को यूज नहीं किया है. मैंने पूरा सारा ये जो यहाँ मैंने कैलकुलेट किया ना, ये सारा मैंने uh, ये सारा मैंने कोड कर रखा है. ठीक है, लाइक दिस ग्रेडियंट डिसेंट वी हैव कोडेड, वो भी मैं भेज दूंगा, तुम पढ़ लेना, मतलब समझ लेना क्या हो रहा है क्या. ठीक है, एसक्यूएल हम सीखेंगे बिकॉज वो तुमको इजी कर देता है. बिकॉज बैक ऑफ द हैंड यही चीजें चल रही हैं, बैक ऑफ द हैंड यही चीजें चल रही हैं. तो लेट अस ओपन आवर गूगल कोलैब. लेट अस ओपन द गूगल कोलैब. should we start should we start? Just give me a second, let me actually connect my keyboard. Okay, till then whatever data set I have given you, kindly put it in the file and upload it. Kanishka, ग्रुप देखो मैंने भेज रखा है कुछ डेटा सेट. दीज टेस्ट एक्स, टेक्स्ट वाई, ट्रेन एक्स, ट्रेन वाई एंड इंश्योरेंस. हम लोग इंश्योरेंस वाला देखते हैं. ट्रेन एक्स ये सब का मैं तुमको नोटबुक भेज दूंगा. ठीक है, आई विल सेंड इट. इम्प्लीमेंटेशन पार्ट, ठीक है. आई अज्यूम कि ये डेटा सेट तुम लोग ने अपने नोटबुक में अपलोड कर लिया होगा. ठीक है, तो शुड वी स्टार्ट? गिव मी अ थम्स अप इफ यू आर ऑल सेट टू गो. ठीक है, सो एज यूजुअल सबसे पहले हमें जो लाइब्रेरीज हमारे लिए जरूरत है, वील इंपोर्ट द लाइब्रेरीज. वील जस्ट अ सेकंड, व्हाट हैपेंड? ओके, we'll import the libraries. What all libraries do we need? As usual, we'll use pandas because हम data frame में work करेंगे. We'll use matplotlib, numpy. ठीक है, these are all what we're gonna use. Now let's hover and let's load this data set. ठीक है, we'll get this data set. So as usual, we have this pd dot read function, read csv, and this part we'll have our address. How do I get the address? You can go here, you can copy path, and you may put it here. And now this part is done. Okay, so my data set is right now. Now let's see what all things are there in the data set. Okay, oh, my mistake. So yeah, we have two columns, age and whether the person has bought the insurance or not. It is 0 if the person has not bought the insurance. It is 1 if it has bought the insurance. Okay, so this is what your data set is. Let us see how it is scattered, how this entire data set is actually scattered in the space. Let's plot some scatter plot. What I want to see, I want to have plt.scatter because we're gonna get some. We're gonna have some scatter plot, and obviously यहाँ से तुमको एक चीज पता लग रहा होगा कि this age is your independent factor. Based on this age, whether the person has bought that insurance or not is dependent. इस factor पे depend कर रहा है age पे. तो intuitively the x axis would have the ages, right? The x axis will have this df dot age, comma, in y axis I want to have df dot bought insurance. And how do I want my marker? I want my marker, कैसे रखते हैं? I want my marker to be equal to some, let us have a plus sign because वो अच्छे से देखना भी है, and let us put it as color should be as usual my red. Nothing new in this. So using let us run this thing and let us see how it is scattered. So you see, this is how your data set is scattered. You have this x-axis and you can have this plt.x label. Okay. This is your age, and you see your y-axis is varying between 0 and 1. 1 is for the person, like there is either two cases. या तो person ने buy किया होगा, so that is clearly 1, or either the person has not bought it. There is only two discrete value you can get. It is not something continuous. Continuous यहाँ पे ये नहीं है. Whether if अगर वो continuous होता, then we would be dealing it in regression. We are dealing it in categories. If you could remember, मैंने बताया था, in classification we deal with categorical variables. So this is what categorical. Either the person has bought that insurance, that is category 1, or the person has not bought it, another category. So this is how your data set is. If you would have to draw some line, you can have a line something like a straight line like this. इससे हो जाता. But if you would make a regression line like this, ये पॉइंट के कारण यू बेसिकली होता है ये कि जब हम रिग्रेशन लाइन ड्रॉ करते हैं ना, तो जो एक्सट्रीम वैल्यूज होता है वो हमारा खेल खराब कर देता है. जैसे ये सब पॉइंट है, दीज आर इन रेंज चल जाएगा, बट दीज आर एक्सट्रीम वैल्यूज. जैसे यहाँ पे तुमको दिख रहा होगा 20 और 30 के 25 के रेंज में करीब. फिर ये दोनों पॉइंट नीचे का, दीज आर एक्सट्रीम वैल्यूज. इसके कारण में रिग्रेशन लाइन थोड़ा टिल्ट हो सकता है. अब वो टिल्ट होने के चक्कर में मैंने वहां पे बताया था एक्सप्लेनेशन में. हाँ वंशिका.
भैया एक मिनट स्क्रॉल कर दीजिए.
ठीक है, कितना पार्ट वंशिका?
यस भैया.
ठीक है, चलो. अब if you would see here, this is how your data set is. अगर मैं इसमें regression problem use करता, if I would be using some regression problem based on the extreme values. मेरा regression line कभी भी, पहली बात तो 0-1 के रेंज में आता नहीं, because this is something I wanted. Moreover, वो discrete भी नहीं आता. अगर 0-1 पे हम कैसे ना कैसे restrict भी कर देते तो it would be कहीं 0.4 आता, कहीं 0.2 आता, कहीं 0.6 आता, 0.8 आता, something like that. तो फिर मेरे को राउंड ऑफ करना पड़ता. अगर वो 0.5 के ऊपर है तो टेक इट एज 1, अगर 0.5 के नीचे है टेक इट एज 0 होता. ओके, नाउ लेट्स डू व्हाट. हमारा डेटा सेट ऐसे है. अब जैसे द नेक्स्ट स्टेप व्हिच वी डू एज यूजुअल, वील split the data set. So for that we'll use the test train split module from sklearn. So from sklearn dot model selection, you may import test train split, because this will do what? This will split your data set. What I'll do, will split the data sets. When we split it, we have this normal convention. We have something like x train, x test. You have something as, oh, just a second, let me make it all capital. Y train, y test. Okay. And now what we want to do is, there is, if I could make you share this thing, test train split module. Just kindly open it on your browser. Let me share it with you. There is this function again, test train split. So we'll use this thing. We have used this, and now let's see how am I gonna test train it. Okay, like something like this. Control C. I'll Head back here, equals to, I want it in one line only. अब now you may see, just tell me one thing, if I go here and if I print df of age, you have this value. Okay, you have this value. But if I देखो क्या हुआ, if I'm just putting it in one, you have a data set like this. You may work on this, but a better option is to go for this. Now your data set is in a data frame. So I'll use this data frame. How am I going to use this data frame? I'll say that use age here as my x. And what do I want it in y? I want that this factor df dot bot insurance, this should be in my y. S size, I want it as 0.2, and random state is something you may take whatever you may choose to simply ignore it, no issues, because it just says how randomly will it shuffle between test and train value, kaise wo karega. So let's see what are my values. Let me see for some values. Let me see. You see, you have this data frame. Let me have some X train. Okay, perfect. Now let's do what? Let's move ahead and actually import this logistic regression. If I could share you this screen, you can go here. There is this, there is a model. Just a second, paste and yeah, in a leader model, you may go to this logistic regression, and now you are good to implement logistic regression. How do you use it? See, there is, first you have to import this thing. Chalo, theek hai, we'll see what are the different parameters you can work. There is this penalty, and you have this L2, L1. These are type of regularization, like L1 regularization, L2 regularization, your elastic net regularization. We'll see what it does. You have this fit intercept. These are the different attributes you can work on it. Let's go back down for some example. Okay, first you have to use, okay, from sklearn dot linear model import logistic regression. Okay, I'll use it here. From sklearn import logistic regression. Now what is remaining? If you would see, there is this function logistic regression. Okay, we'll use that logistic regression function. If you could see here, है क्या ऐसा? No issues. Sure. There is this function logistic regression. We'll use it straight away. Control C, head back, share this tab. Let us say that my model is this logistic regression. So once your model is ready, we are up for fitting the data. अब हम data को fit करेंगे. So if you would go again to this documentation, you may see there is this function which is known as dot fit. इसने एक line में कर दिया, but you may choose this is fit, in which you have to pass on the x, where x would be your array, y would be your target values. These are your training vectors. So okay, let's use this. We'll use this fit function, fit attribute. Sorry, what I'll say model dot fit, and on what parameters do we want to fit this value, we say कि ठीक है ऐसा करो, पहले तुम ट्रेनिंग डेटा के लिए इसको चेक करो. Okay, I can do it like this. So now you are good to go. You have completely trained your model on logistic regression. Now let's do what? Let's see that. Okay, let me show this thing first. Let us see what our test values do we have, because on that value we will test it out. So these are the different test values. Now let us see, can we actually predict it? So let's see if there is any function for that predicting. Yes, there is this function, or there is this attribute which is known as predict, in which we have to pass on x. And what will it give me? It will give me a vector, basically a matrix, something like that, containing the class label for each sample. हर एक sample के corresponding उसका जो prediction होगा, it will show. Let us do it here. So what I say, let's say my y predict should be, it will equal to model dot predict. And what do I want to pass? I want to pass this thing. Ye data frame I want. I can have it like this. Control C. I'll pass it here only. And let's run this. Now it is ready, and let's see. So based on all these values, you can see if it is pretty obvious that if any person who is of age 62, he would buy that insurance. Make sense? Thoda? Let me also print y test correspondingly. So see, for this index 8, that is your age 62, that person has actually bought that insurance. Let us see for some other values. For let's say 29, that person has not bought it. The person has not bought it, but that is what our model says, and exactly it is what it is in the test data set. So our model is working pretty nice, but is there any way to see what score are we like? There are some, let me show you here. Do we have something? We'll work with this predict probability. We'll work it. There is a score. It gives you the mean accuracy. Let us see what is our mean accuracy. I'll simply write your model dot score, and on what value? Just a second, caps lock. Model dot score, and let us work it for x test and y test. Let us see what score do we have. A perfect 1. A perfect 1 we are having.
भैया
हाँ,
आपकी स्क्रीन फ्रीज हो गई है.
just a second. So what I did, my mistake. I've made this function model.score, in which I've passed on the test value and the x test, and I'll map it to y test, and I'll get my mean accuracy. So my mean accuracy is simply 1. Pretty obvious. कुछ इसमें ऐसा नहीं है. So now let's work on some other kind of function attributes. Let's say there is this, if you could see here, let me share this thing. There is this predict proba, because what it will give you, it will give you the probability estimates. It will give you the probability estimates. Okay, let's go here. Perfect. So how do we work on it? Okay, the model, we'll have this, we'll use this function, this attribute function बोल देता हूँ. So I'll have this, and in this I'll pass on what values do I want to get my probability. Perfect. What does it say? See, you are having two values, correct? You're having two values. In this list, you have different indexes, and for different indexes, you're having two values. What does this says is this is for class 0 and this is for class 1 for whatever value you see. The first, these are your first entries. If I could show you 0.5, 0.7, 0.6, 0.77, something like that. These are your first, sorry, this belongs to the class 0 जहां पे उस बंदे ने इंश्योरेंस नहीं खरीदा है. The second one is for class 1. So what does it says? Ki for the very first value, that is x of age 62. Sorry, for the age 62, what does it says? That there is a 94% chance that that person belongs to class 1. That is, he has bought the insurance. What does the second value says? It is 70%, it is to 30%, close to 30. So it says for the second value, you may see from the actual result, you may see there is a 70% chance that the person is belonging to class 0. That means that person has not bought the insurance. That the person has not bought the insurance. Because why am I gonna why are we even dealing with this? We'll see there are certain kind of problems, especially multi-class classification, in which we'll use the same method to build a logistic regression model for different classes, more than 2 classes. So this was pretty obvious. You got this thing. So can we use can we get some kind of intercept as usual? Like we are also dealing with that beta. Now there was this beta transpose. Can we have that? Yes, we can have that. Model dot coefficient. You can have the coefficients. This is the coefficient. You may also get some intercept. You can have some intercept. As usual, model dot intercept underscore. You'll get the intercept value. So this was all with your sklearn. Can we actually go out and build something without sklearn? Let's see. थोड़ा सा time है. We'll see. We'll see. So in order to build that thing, we saw कि we have that sigmoid function, right? Sigmoid function था. If I could make you recall, let me show you this screen. There was this sigmoid function कहाँ गया? Yes. There was this sigmoid function. And based on this function, I was able to get my values. Based on this function, I was able to get my values. Okay? Now let's try to actually implement it here. How am I gonna get that? We'll need this intercept, we'll need this model. So let us do what? Let us there is this function import math. This is function. Okay? Because इसको use करके whatever mathematical operations we want to perform, we can perform it very easily. So let us do what? Let us make a sigmoid function. Def sigmoid, and in this sigmoid we'll have some x. So once I pass it, what should it should return me? It should return me 1 over 1 plus, there is this function known as math.exp, and in this I'll pass on the parameter, that is minus x. So you may simply, if you would not like to use this, you may use something as equivalent as return 1 over 1 plus, you can have something as 2.71 raised to the power minus x. You can also do like this, no issues, but I'll prefer to use the first way. Okay, now let's run this thing. So it has worked now. Okay, Now what I want, can we predict it? Yes, we can. Obviously, we can predict it. Yeah, we can obviously predict it. Can we make some function on it? Yes, we can make some function. Let us have a prediction function. And what will I pass here? I'll pass my age. Okay, I'll pass my age. Now, if you could see here, what all factors do you need to get the prediction? What I mean to say, just see here. If I could make it something like this, just a second. Just tell me if it is visible or not. Let me open my OneNote. Perfect. What do I want to see? Like, is it visible? Yes. Once you get your M as C, this is your slope, this is your intercept. Once you get this, you can always go on and build a function, hypothesis function of something of the order mx plus c, where this is what you have got using the sigmoid function. You got this using your sigmoid function. I can build that. So let's do, and let's go on and predict this. It is very easy. Just tell me if it is visible or not. Because see, more or less, there is one more option. You may actually go on and implement gradient descent. I'll not be doing it in today's session. I'll rather give you the notebook, because gradient descent is what I have already taught you. और हमको बस इतना करना होगा, इस prediction वाले function में I have to implement that gradient descent to get me the optimal values of m and n. So you see, if you have to build some hypothesis function, how do you build it? Let's say my hypothesis is h. So pretty obvious, your coefficient times your x plus your intercept. This is your hypothesis function, and we'll pass it in the sigmoid function. I'll say my return should be this sigmoid h. I'll pass it there, and let's see what values do we get. Let me run this thing. Perfect. Control MB. We'll go down, and let us see from here. Do we have some values? Okay. So see, if your age is 61, you are actually buying it. So let's see. Let us run this thing. Let us take my age to be 61, and let us run this prediction. So you see, you are getting a value which is very close to 1. आ रहा है सबका? आया? वंशिका, हर्षिता, श्रेया, तनिष्का, शशांक. You may use some other values. यहीं से देख लेते हैं. Let us say 29, and 29 is corresponding to 0. That means person has not bought it. I'll have 29 here. Let's run this. 0.2, which is less than your threshold, that is 0.5. So you are able to implement it. Is it clear? Is it clear? Perfect. So can we go on and move to this another topic, which is in this only, which is known as multi-class logistic regression. We'll have this another topic which is known as multi-class logistic regression. We'll have, अभी तक हमने जो भी देखा, this was a kind of binary classification. How was it binary classification? because either it was true or false, or yes या no, or it was 0 या 1, something like this. अभी तक जितना भी हुआ वो more or less यही था, correct? What would happen, जैसे मैंने एक example तुम लोग को दिया था, that what would happen, let's say if you have some pictures, let us say you have some pictures, and you have some prediction. Let us have something like this. Like say if this is a figure, so the prediction should be it is a triangle, right? If this is your figure, the prediction should be that it is a circle. If this is a picture, it should be a square or a rectangle, whatever you may choose. No issues. If this is your figure, okay, let me change it. We have some other figure. If this is your figure, the prediction should be it should be a kite. So you may see here there are different classes in which the picture should can belong. दो से ज़्यादा classes हैं. Essentially हो क्या रहा है? Essentially हो ये रहा है कि given a set of picture, there are only a number of classes in which these picture may belong. 1, 2, 3, 4. It could be either a triangle, it could be either a square, a circle, or a kite. अभी के लिए हम इतना ही ले रहे हैं. And you have this, you have these different pictures here. So can I say these pictures may belong to either of one of the 4 classes? Pretty obvious to say, right? इन्हीं 4 में से कोई एक होगा. Kind of. Vanshika, Shashank, makes sense? So the question arises, see, if you would use this sigmoid function, it will only give you value between 0 and 1, right? This is only giving you values between 0 and 1. How can we use this same concept to build a multi-class regression, multi-class logistic regression? We can do it very easily, but it only makes sense if you want to do it by logistic regression only. There are different optimized algorithms better than this to handle such cases, multi-class regression. See how do we do it. Let us for say there are only 3 classes. So your y is only out of, let's say, triangle, square, and circle. These are the only set of outputs which is possible. So let us say if there is this figure, if I pass it in our hypothesis function, what should be my output? It should be somewhere around 0 because this is not a circle. Oh, let us say this is for triangle. This hypothesis function is for triangle. So if I pass this figure in this hypothesis function, this is definitely not a triangle, right? Triangle ही नहीं है. So output should be a 0. This is my input. Okay, let us take this. If I pass this thing with our hypothesis function for triangle, will it give 0? Will it give 0? Yes, it will give me 0. If I pass this triangle in our hypothesis function for triangle, will it give me 1? Perfect. Acha. Let us do it for some other case. We have the same example, 0, say circle, triangle, you have your input. ठीक है वंशिका, कोई issue नहीं. So if I pass this circle in a hypothesis function which is for a circle. So can I get an output as 1? If I pass this square in a hypothesis function which is for circle, will I get a 0? Similarly, if I pass it for circle, I'll get a 0. So you can see, for as many class you may have, you have to build some hypothesis function. अच्छा चलो अब ऐसे देखो, if I take it for a figure, let's say your figure is a circle. So you can have a hypothesis function for triangle, you can have a hypothesis function for a circle, you can have a hypothesis function for a square, right? So for this value, if the image is circle, your hypothesis function for triangle would be 0. Pretty obvious. It would be 0 for square and this would be 1 for the circle. If I take it for some triangle, the hypothesis function with respect to triangle would be 1 and rest of them will be 0. If I take it for some square, it would be square for 1 and rest 0. So what I'll do, I'll take a maximum. I'll take maximum. इन तीनों में से सबसे बड़ा कौन है? This is 1, 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 this is 1. And this one corresponds to your hypothesis function for triangle. Circle, my mistake. For circle, this one corresponds to your hypothesis function for a triangle and this corresponds to your hypothesis function for a square. 1 तो तीनों ही केस में आ जाएगा तुमको, maximum 1 ही रहेगा हमेशा. The maximum would be 1 only. But the question comes कि 1 किस hypothesis function से आया? तो ये केस में ये ट्रायंगल से आया, ये केस में ये सर्कल से आया, ये केस में ये स्क्वायर से आया. तो जिसका सबसे ज्यादा है वो उस क्लास में बिलोंग करेगा. आया थोड़ा थोड़ा. कनिष्का, तुम थोड़ा सा लेट ज्वाइन की थी, बट आई अज्यूम कि थोड़ा थोड़ा आ रहा होगा. Perfect. So similarly, you can actually build 3 hypothesis functions if you're working with 3. You can run them together. What I'll say, let's say your sigmoid 1, sigmoid 2, sigmoid 3. You may run this together. You will have some values, and you will take the maximum. Whatever value you will get, you will simply find its class, जिस class से वो belong करता है. So that is how you actually implement a multi-class regression. But you can see इसमें बहुत झंझट है. 3, 4, 5, 6, 10 क्लास हुआ तो चलो फिर भी ठीक है. बहुत ज्यादा क्लासेस हुए तब तो ये उतना एफिशिएंट नहीं रहेगा, राइट? प्रीटी ऑब्वियस. मेक सेंस? तो अगर 2, 3, 4, 5 केसेस हैं तो यू कैन वर्क ऑन दिस, नो इश्यूज. यू कैन वर्क ऑन दिस, यू कैन बिल्ड दैट मॉडल. बट आई वुड highly suggest you to implement this thing only with binary classification. But हाँ, तुम्हारा चॉइस है. यू में गो आउट एंड से भैया हमको और के लिए भी करना है, तो हाँ तुम कर सकते हो. इट इज ओनली दैट तुमको उतना सिग्मॉइड फंक्शन बनाना पड़ेगा, समझे? उतना तुमको ये बनाना पड़ेगा. अदरवाइज कोई झंझट नहीं है इसके साथ. यू कैन, इफ यू कुड सी द कोड, मैं तुम लोग को दिखाया. Let me show you the code. Even without using the actual your logistic regression function, inbuilt function, मैंने सिंपल जो इंटरसेप्ट होता है, मैंने इंटरसेप्ट उठाया, मैं वहां इसको जो नॉर्मल हमारा रिग्रेशन इक्वेशन होता है, रिग्रेशन इक्वेशन में पुट किया, एंड आई गेट माय वैल्यू प्रीटी क्लियरली. Pretty, like, to some extent I'm getting my values. So should we wind up आज का सेशन? अब this was all about your logistic regression. You can work on different equations. You can build some models. मैंने कुछ टेस्ट ट्रेन डेटा सेट दिए हुए, मेरा मन था वो लगाने का, बट सिंस यू हैव सेड कि यू वांना डू इट बाय sklearn, ठीक है, we'll do it by sklearn. We have this very important function logistic regression, और we'll simply fit किए डेटा को, we get the score. हमें स्कोर इसलिए चाहिए होता है because we want to know कि कितना अच्छा हमने कोड लिखा है actually. because कभी कभी ये होता है, यहाँ पे तो 1 आ गया मेरा, बट sometimes because of some outliers your value is not something which you want. हो सकता है कि वो इंश्योरेंस खरीद रहा हो एक्चुअल में, लेकिन हमारा मॉडल प्रिडिक्ट कर रहा है कि नहीं खरीद रहा है. So to deal with some such kind of errors, we need this accuracy score. You can also get this R2 score. You may import that module from sklearn. There is this module to get that. So can I assume कि आज का session was something you got the idea of? शशांक, तुम तो पहले से थे क्लास में. Perfect. So there is this one homework I would like to give it to you. You may actually go and learn about regularization. अगर मेरे पास कोई सेशन में मौका मिला तो I'll teach it, no issues, I'll teach it. But I've assumed कि ये होमवर्क तुम लोग थोड़ा सा अपने साइड से करो. Let me write it out for you. कोड में क्या दिक्कत आ रहा है? जस्ट टेल मी, क्या कोड में दिक्कत आ रहा है? देखो हमने क्या किया है, हमारा डेटा सेट है, हमने उसको रीड किया है. अच्छा, एरर्स तो वो तो डिबग करना पड़ेगा तुमको, उधर डिबग करना पड़ेगा. बट जो स्टेप्स मैंने किया वो स्टेप तो आ रहा है ना तुमको, स्टेप तो क्लियर है ना कि क्या के बाद हम क्या कर रहे हैं. स्टेप्स तो क्लियर है ना. हाँ, दैट इज व्हाट आई नीड. एरर आ रहा है, यू कैन एक्चुअली गो एंड डिबग इट. डिबग कर सकते हो, उसमें कोई इशू नहीं. So let me just quickly tell you one thing. Let me share this. I want this that you should do it by your own DIY. That I want you all to learn about regularization. There are 3 kind of regularization which we use. The first one is lasso, the second one is known as ridge, and the third one is known as your elastic net. ये क्या हो रहा है? हाँ, the third one is known as इसी से अगर तुम ये पढ़ोगे तो यू विल गेट अ नाइस आइडिया अबाउट ओवरफिटिंग वर्सेस अंडरफिटिंग. मैं थोड़ा सा क्विक बता देता हूं क्या होता है. मैं थोड़ा सा क्विकली बता दूं व्हाट दिस थिंग इज. फर्स्ट थिंग इज योर ओवरफिटिंग.
मुझे 1 सेकंड पे थोड़ा स्क्रॉल कर दो.
अरे ये मैं चाह रहा हूं तुम लोग अपने से पढ़ो, मैं इसका दे दूंगा नोट्स, अभी मैं दे दूंगा ग्रुप में, नो इश्यूज. आई वांटेड दैट यू शुड कंप्लीट इट. मैं थोड़ा सा क्विक बता देता हूं. ओवरफिटिंग क्या होता है? ओवरफिटिंग एंड अंडरफिटिंग इज अ काइंड ऑफ डिस्पेरेंसी जो तुम देखते होगे जब तुम मॉडल को ट्रेन करते हो और उसको स्प्लिट करते हो, तब वो होता है ये है कि इन ओवरफिटिंग व्हाट हैपेंस इज that if you're working with training data and there is this test data, ठीक है, what happens is that whenever you are working with training data your model works well, but whenever you are working with test data it fails. ट्रेनिंग डेटा के लिए तो बहुत अच्छे से वर्क कर गया, टेस्ट डेटा के साथ पता नहीं क्या हो गया उसको. बेसिकली हुआ ये कि जो मॉडल है वो ट्रेनिंग डेटा को बहुत अच्छे से समझ गया, इतना अच्छे से समझ गया कि अब उसको बाहर का कुछ मिल रहा है तो वो उसको कॉम्प्रिहेंड ही नहीं कर पा रहा है. अगर कोई सेशन में मौका मिला तो आई विल कवर इट अप, बट एक ब्रीफ के लिए मैं यहाँ बता दूं. So basically what is happening is when your model is working well with your training data, this is known as this is when your model is working well with your test data, this is known as low bias. And when it fails to work with your test data, this is known as high variance. Same is for underfitting. You again have this thing, training and test data. You have this test data. So what happens is in underfitting, that it fails with training data, and out of nowhere it performs well with test data. So if it fails, that means it is a high bias and high variance. इस पे हम ज्यादा अभी डेप्थ पे नहीं वर्क करेंगे, बिकॉज ये इशू आता है जब हम पैरामीटर्स के साथ अच्छे से वर्क नहीं कर पाते, जब हम पैरामीटर्स के साथ अच्छे से वर्क नहीं कर पाते. So if I go here, so this is what I want you to learn. Lasso is somewhere called as L1 regularization. This is known as L2 regularization. होता ही है, बस होता ही है कि whenever see what happens, होता ये है कि ऐसे समझो जैसे हम लोग घर में मम्मी लोग अगर हमारा आंसर नहीं आता है तो हम लोग थप्पड़ मारती है ना, कोई क्वेश्चन दी नहीं हुआ, चटाक से थप्पड़ लग गया, ऐसा कुछ. तो whenever you are not performing well, we add some kind of penalty. That is this regularization is. ठीक है. There is this lasso, there is this ridge regularization, there is elastic net. 3 होता है बेसिकली, जो तुमको आई अज्यूम कि तुम लोग पढ़ के आना नेक्स्ट सेशन में. अगर मौका मिला तो आई कवर इट अप, अदरवाइज लेट्स सी. अगर लाइक 2 मिनट, अगर मेरे को 5 मिनट दोगे तो मैं थोड़ा मतलब मैथमेटिक्स कवर कर देता, इफ यू वुड गिव मी 5 मिनट्स. कैन वी डू इट तनिष्का, शशांक, 5 मिनट में कैन वी डू इट? चलो बता देता हूँ. इलास्टिक तब देन डू इट बाय योरसेल्फ. See what happens in lasso regularization. This is also known as L1 regularization. What happens? What was your error function? Your error function was y minus y hat square. ये था error function. What we essentially do is we add this parameter in our cost function or your loss function. ठीक है, we add this. What this lambda is, your lambda is known as your cross validation hyperparameter. ठीक है. So, and what this slope is simply, you know what is. हमने इसका absolute value इसलिए लिया हुआ है because what it does, it prevent overfitting. ठीक है. This is the kind, बस देखो there is this additional penalty which we are adding. ठीक है, इतना तक तो लॉस फंक्शन हमारा जो था वो वैसे का वैसे ही. This is the additional parameter component which we are adding. ठीक है. Now let's go for ridge regression. See, essentially, as usual, as you have this y minus y hat square. What you do is you take the square of slope. As simple as that. Nothing obvious. You add just this term. Okay? So while calculating, if you're working without any kind of स्केल लाइक अगर तुमने देखा होगा स्केलर में लॉजिस्टिक रिग्रेशन के नीचे था एक लॉजिस्टिक रिग्रेशन सीवी था ऐसा क्रॉस वैलिडेशन, तो वहां पे ये यूज होता है, वहां पे हम ये यूज करेंगे. If you want to work with L1, you can simply assign L1 there. If you want to work with L2, you can simply assign L2 there. और ऐसे इसमें कुछ नहीं है, इसमें और कुछ नहीं है आई गेस. परफेक्ट. तो शुड बी वाइंड अप आज का सेशन? हर्षिता, शशांक, श्रेया. परफेक्ट. और नहीं, और कुछ नहीं. So let's meet hopefully a day after tomorrow. We'll see what is in our next class. Thank you, Sashant. उस टाइम के लिए sorry. This is Bihar overall. ये सब होते रहता है. अरे mathematics. See, ये सब सीधे फंक्शन है. There is function. See, logistic regression import कर लो, do it. But मैं mathematics इसलिए बता रहा हूँ because अगर तुम्हें कुछ परोस के दे दिया जाए तो तुम बना लोगे. बट व्हाट इफ देयर इज समथिंग व्हिच इज नॉट इन योर हैंड. अगर डेटा कोई दूसरा आदमी दे, डेटा अभी तो मैं तुमको दे रहा हूं तो मैं इसको देख के ला रहा हूं कि डेटा सही रहे. अगर डेटा तुमको अपने से कहीं से लाना पड़े और वहां पे कुछ छेड़छाड़ करना हो तो दैट इज हाउ यू डील विद इट. ठीक है. तो कोई इशू इसमें? कोई इशू? So let us meet in our next session. We'll have some other topic to discuss. Till then, good night.